this meeting and we're going to start. So this second chapter, I mean, the first chapter, I apologize, I didn't emphasize all the topics. I think we are I'm kind of like not very happy with 1 hour and 15 minutes because I have no time to go through all the topics I would like to cover. So for me, it's more restrictive. I used to do this class in a 3 hours class. So I have more time, more freedom, but we do what we can do. So today we're gonna start with chapter number 2. We're gonna look at the descriptive statistics. So that's very interesting because remember we mentioned that descriptive statistics allows us to make a visualization of the information. So I have a bunch of numbers. Those numbers, I don't know what they are. So it can be anything. So we can do some arrangements of the data, and we can present it in such a way that we can be more effective in describing the problem that we need to describe. So far, we're going to use several techniques. So we're going to be using graphs. We're going to be using tables. We're going to be using some other type of descriptions that we need to use in order to present the data and make the data available to people. Generally speaking, we have an audience. Your audience can be your boss. It can be, if you are a researcher, you are doing research and you are aiming to inform people that might be interested in your topic. So in my case, I want to present this data because I have an audience who are my students. So so this is it's very good that we learn these things because so once again, the goal of our class and especially when we become employees is to make things easier for our bosses. And even more, when you are the boss, I think it's also good. So let's start with this. So the first thing that I want to show is how to create a frequency distribution table. Probably you know this very well. So we are going to be using very primitive tools for Excel. So so a frequency distribution table is a table that shows classes or intervals of data with a count of the number of entries in each class. For example, this is going to be a class. Just imagine that you live in a big building and you want to collect the data on the ages of all the tenants. So you are administrating a big building, so you want to know what are the ages, because what if you have more older people or younger people? So if you have younger people, you probably want to create spaces for the kids. If you have older people, you probably are gonna be building some ramps for people who cannot climb the stairs, so forth and so on. So you collect the data and just imagine that you have a bunch of entries. So you have entries from your subjects. So what can you do with the data? Well, you can have a person who is 1 year old, 2 year old, you can have 120. So, so you have all the data points. So what you are gonna do is to categorize these in different classes. For example, if I was looking at the data, I will be interested in, for example, categorizing the data in 3 or in 5 at least different classes, or probably more, between 5 and 7, let's say. I will put people who are 0 and 10 years, 11 to 20, 21 to 30, 31 to 40, so on and so forth. So I'm gonna categorize them in that particular order. So I'm gonna create classes, and those classes are gonna be bounded by a lower and an upper limit, right? So once I categorize this by the lower and the upper limit, I'm gonna count the number of elements that fit in that particular category, right? So, and then we're gonna do the same with all of them. So that is very important because one of the things that I can see here is the distribution underlying this data. So I cannot see it in these numbers, but if I organize it in a frequency distribution table, I will be able to do it. So how do we construct these frequency distribution tables? So we know that those are tables that are showing different classes and intervals, and then the frequency of a class is the number of data entries in that particular class. So how many elements are between 1 and 5 or whatever the criteria we are gonna use. So this is how we construct a frequency distribution table. So we are gonna decide the number of classes. So the number of classes is gonna be how many different bars we're gonna build in our table. So in this case, we have like, so the rule says that not less than 5, no more than 20. So if you have less than 5, it's gonna be very difficult to determine any trend or any pattern. If we have more than 20, probably we're gonna make so many divisions that it's gonna be very difficult for me to explain what is the purpose of this table. So, so once we determine the number of classes, so this number of classes is determined by the researcher. For example, in some cases, if I am doing a case of income inequality, for example, 5 bars might be very good for me, the 20% poorer, the 20% that follows, the 20% in the middle, blah, 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 and the 20% richer. So I have different group of people. So 5 bars are gonna be very good for me to explain income inequality, for example. So in this case that we're gonna analyze as a researcher, I determined that 7 classes is gonna be what I want to see. So the determination of the number of classes depends on the preference of the researcher. So once we determine the number of classes, we're gonna find the class width. The class width, so it's gonna be fine when we know the range and we know the number of classes. So we are gonna perform an operation and we are gonna determine what is the class width. So as I mentioned before, the class width, we are gonna determine the range. We're gonna divide the range by the number of classes, and then we are gonna round up to the next convenient number. So, so that means that, for example, if I have, just as an example, 68.4, so that's my class width. So what I'm gonna do? Well, I'm gonna use 69, right? So even though this number is below the 0.5, and it doesn't matter. Even if I have a 64.1, I'm gonna round it up to the next integer. So in this case, from 68.1, I'm gonna use 69. So that's a rule, and if you don't do that, in many cases, some of these observations that you find here are gonna be missing in your counting of the data. So, so we are gonna do this and see why this is important. So once we find the class width, we're gonna find the class limits. So we are gonna have the lower and the upper limits. So we're gonna be able to construct these values. So, and then so once I determine the lower and the upper limit, so I'm gonna count how many of them are in my data. So for example, if I, well, we will give a better example when we are doing the counting. So we are gonna make a tally mark for each data entry in the row of the appropriate class. So count the tally marks, and then that's gonna be the frequency. So, so this is the example, and I took this example from a textbook, different from the one that we have. So the following data set lists the price in dollars of 30 portable GPS navigators. Construct a frequency distribution that has 7 classes. So I know that based on this, I'm gonna create 7 classes, right? So in my Excel table, if you open your Excel table, so let's find the number of classes here equal to 7, right? So that's gonna be the number of classes. So these numbers that you see here are exactly the same numbers that are here. So it starts with the 90 and ends in 150. So I at the bottom, if you see, I wrote a small code for Excel. 6 p.m. I thought it started. No, that's fine. Ariel, I asked a few minutes ago whether we can start at 6 o'clock. Do you have any problem to start the class at 6 o'clock? Please let us know, or let me know, because no, I know that the schedule is 6:15. That's the reason I ask students whether they have any problem for me to start the class at 6 o'clock. But anyways, I think I'm gonna change next time. I'm gonna start at 6:15, okay? So, so yeah, we can respect the schedule. I will start at 6:15, okay? So we haven't covered too much so far. So, so next class starts at 6:15. So, so we have 7 classes in your Excel file. So make sure that you type 7 next to the classes. And I was explaining that in this Excel, I wrote an Excel function. So when I don't know, I don't like to count things. So what I did is I used the equal count, and then I counted all the values here. So Excel is gonna tell me how many elements I have in this bunch of numbers. This is very helpful, because just imagine that you have so many and you don't know exactly how many of them you have. So the count, this Excel function equal count, and then highlight your information, is gonna tell you how many elements you have in your data set, okay? So continue with this. So we're gonna find the midpoints, we're gonna find the relative frequencies, we're gonna find the cumulative frequencies and the class boundaries. So we're gonna produce some graphs that help us understand the nature of the information, of the data. So we're gonna produce a frequency histogram, a frequency polygon, a relative frequency histogram, and the cumulative frequency graph, which is called ogive. So based on this data, we are going to start creating this information, this table, and therefore it's not only the table, but how we present that information in our to our peers. So if you are watching this video once again and you have your Excel file, please open your Excel file and click on the 90, highlight all the, or you don't have to. Well, so I'm gonna do something different. So you have to highlight all your information. So I'm gonna do the same, command copy, and I'm gonna copy in a different cell, right? So I say command copy, and then I said command paste. So this data, you don't have to copy it again. So I'm gonna do something that is gonna order my data, but I want you to see the difference. So so this data and this data are exactly the same. So what I'm gonna do is I'm gonna highlight it, and don't have too much space in this small. So so if you open your Excel file, you are gonna look at one of the this sort and filter. So I'm gonna ask Excel to order the information from the lowest to the highest. So I want you to look at the 2 columns. You can do it directly in your data. So you click the sort and filter, and you ask Excel to order or sort from the smallest to the largest. So you are gonna find, it says expand the selection, say no. In this case, we're gonna continue with the current selection, okay? So I'm gonna sort. So as you can see, I have the data from the lowest to the highest. So you can do it directly here, and nothing is gonna happen. So I do this in order for you to see that you can order your information and you can see the difference. So one of the things that we can do is order our data. So there are some other Excel functions that can help us do the work that we want to do without ordering the data. But at this point, it's more convenient to do it in this way, okay? So the rule says once that you find, so you know the number of classes, right? So let me, so can you guys see well in your computers? Should I make it a little bit bigger? 125 probably. So that's a little bit bigger. So if you have problems to see what I'm doing, please let me know. So remember that one of the things that we were looking at is the fact that we have to decide how many classes. We already, the exercise is asking for 7 classes. So we are gonna find the class width, and it says divide the range by the number of classes. So we have to find the range first. So in this case, the range as defined is gonna be the lowest value. In this case, we have a lowest value, which is 59 minus, sorry, it's the opposite. So is the highest value minus the smallest value, right? So the range is gonna be defined by the highest minus the lowest. So, and we are gonna find the class, the range. So I'm gonna highlight this with yellow because those are informations that we are including in our computations. So, so we have a range of 391. So we have 7 classes. Remember, the class width is gonna be dividing the range by the number of classes. So, and my class width is gonna be 55.85. Remember, I said we have to round it up to the next integer. So I'm gonna be using 56, right? So what is next? Well, I need to start building my table. So I need to find the lower limit and the upper limit. So for the lower limit, I'm gonna use the first data, right? It's gonna be 59. So I'm gonna type 59. So to this 59, I'm gonna add the class width. So in this case, the class width is 56. So I'm gonna ask Excel, whatever is here in the previous cell, add 56, right? So by doing this, we are adding 56 to 59. And then we get this number, 115. So if I drag this cell down, I am gonna create a formula that says, like if you see here, we have 59. I am instructing Excel, whatever is in the previous cell at 56. So I drag this down and I said, whatever is in the previous cell in E3 at 56. So this is gonna be my first, my lower limit, right? So once again, I can do it by hand. I can add 59 and 56, whatever I get. I'm gonna add this number to the next one. So I'm gonna add 56 to this number and I'm gonna get this number. For the next class, I'm gonna add this number to 56 and I'm gonna get this number. So that's the way we did it. So every time we're going down the road, so we are adding 56. So for the upper limit, I'm gonna just subtract one number from here. I'm gonna say 114, right? So why? Because if I put 115, they are gonna overlap. They should not overlap, right? So I'm gonna do exactly the same. I'm gonna ask Excel, whatever is here, add the class width, which is 56. And you might ask again, where is the 56 coming from? Remember, is the rounded number for the class width, right? So, so we are gonna be adding these numbers. So, so at this point, so we have 30 observations. We have 7 classes. I want to know how many elements between 59 and 114, between 115 and 170. So that is gonna be my frequency. For example, in the first frequency, I'm gonna count how many elements we have. For example, all these numbers are lower than 114. So I have 1, 2, 3, 4, 5. I'm gonna put a yellow color. So I have a frequency of 5. So for the second is between 115 and 170. So I have 1, 2, 3, 4, 5, 6, 7, and 170, right? So I'm gonna put another color, something very light. So I have 1, 2, 3, 4, 5, 6, 7, and 8. So once again, we can do this with another Excel function. It's a little bit more complicated. I don't want to complicate this. So from 171 to 226, so I have 1, 2, 3, 4, 5. So I'm gonna use 226. 220 is still part of this. I'm gonna use another light color. So I have 1, 2, 3, 4, 5, and 6. So I have 6. For 2027 to 2082. So 1, 2, 3, 4. So these are within the ranges I want. So I'm counting, as you can see, I'm counting how many elements I have between these two numbers, right? Between the lower limit and the upper limit. So this is my class. Between 59 and 14, I have 5 elements. Between 115 and 170, I have 8 elements. So between 227 and 228, I have 1, 2, 3, 4, 5. So so we can go down the column. So it's between 283 and 338. 283 and 338, we have only 2. So we're gonna use another color here. So we have 2 elements here. And then between 339 and 394, so I have only 1 element, right? So I have only 1 element. So, and then between 395 and 450, I have 3 elements, right? So did I did everything right? Well, I don't know yet because I probably made a little mistake. I'm gonna use this sigma. As you can see, this Greek letter is for the summatory. If I just click this, Excel is gonna recognize that I want to add all those numbers. So I'm gonna click, and yes, I have 30 numbers. So my data set, my sample size is gonna be equal to 30, which is exactly what I did here. So I counted electronically all the elements of my list, and I realized that it's 30. So I didn't make any mistake. I was very careful to do this. So also in this, we are gonna find the midpoint. So the midpoint is gonna be the average between the lower and the upper limit. So I'm gonna add these 2 and I am gonna divide it by 2, right? So that's gonna be my midpoint. So I'm gonna drag this down and I am going to create all the midpoints. Question, are you guys following what I'm doing? Yes or no? Hello?
Yes.
Okay, so yes. Those who are not, please let me know. I am gonna, I mean, I can do it again, but if you know Excel a little bit, and if you watch the videos I sent, it shouldn't be any problem in creating those values. So remember, in this case, I am using a formula. So I am asking Excel to add E2 and F2 and then divide it by 2, okay? I use parentheses because if I don't use parentheses, look what happens. So if I don't use parentheses, I am instructing Excel to divide F2 by 2 and then add it to E2. So the value is different. So I want Excel to add E2 and F2 and the result is going to be divided by 2. So those are my midpoints. So these midpoints are very important, and once again is the average of the lower and the upper limit. So when it comes to the relative frequency, so to find the relative frequency, so the relative frequency is going to be equal to the frequency, so this number, divided by the sample size. And remember, the sample size is n. So in this case, what I'm going to do is I'm going to apply this formula, and I am going to find the relative frequency. So the relative frequency is basically the percentage. What is the percentage of this number of observations regarding the sample size? So here I'm going to do equal. So this is my frequency, and it's going to be divided by the sample size. I'm going to make a little trick here because I am going to divide all the frequencies by the same number. So because of doing this, I'm going to add a $sign near to the G and a $sign near to the number, okay? So I'm going to add, so what does this do? Well, I'm asking Excel that every time I'm going down the road, these frequencies are going to be divided by the same number, okay? So I'm going to click. So I'm going to drag this down, and I have all the values, right? I don't like to see too many zeros. So if you have if you are doing this in Excel, so you can decrease the number of decimals, right? So that is very helpful. Sometimes there are so many zeros that you get lost. So you can control how many zeros you want in your computations. So how do I know if I am right? So I'm gonna also click in the summatory, and the summatory of these numbers should be equal to 1. Why? Is the 100%. If you have 0.167, 0.267, so all these numbers should be equal to 1. So if I did the right thing, so I'm gonna get this number as 1. So the cumulative frequency is going to be the addition of the, well, in the first number is going to be equal to the first frequency, which is going to be 59, right? So the second, sorry, it's going to be 5. Sorry, 5. So that's frequency number 1. So the second cumulative frequency is going to be frequency 1 and frequency 2. So I'm going to do equal whatever I have here plus what is in this line, right? So, so that is going to be the second. So I just have to drag this down, and the last number should be 30. So we have 5, and then the 5 and 8 is going to be 13. 5, 8, and 6 is going to be 19. Then 5, 8, 6, and 5 is going to be 24, so on and so forth. So that cumulative tells me that the last observation is going to be equal to the sample size. So what can we do with this information? So I am wondering how I can visualize this information. What I'm going to do is I'm going to take the midpoints, I'm going to copy, and I am going to paste it in another place. But listen to this. So these are not numbers. As you remember, these are formulas. So what I'm going to do is I'm going to say edit, and I am going to say paste special. So I don't want the formulas, I want the values. So I'm going to paste the values, and I am going to create a column with the values. If I don't do this, so I paste, and you can see that it gives me different numbers. Why? Because behind this, there are formulas. So I don't want that. That's the reason I said copy, paste special, and I asked for the values. So now I'm going to copy the frequencies. I'm going to create a frequency histogram. So remember, the frequency histogram is going to be a graph. It's going to be a bar graph that shows me the underlying distribution of my data. So in this case, for practicality, I do that. You can do it in some other ways. So I'm gonna erase the label of the first column. I'm gonna highlight everything. I am gonna go to insert chart, and I'm gonna ask for a column graph, right? So this is basically not a histogram. So here in insert, so we have, I think, a way to create histograms, but this histogram is not what we want. So we want a histogram which is made out of bars and continuous bars. So we are gonna make a little trick here. So if you are doing this, right click. So let me do it again. So you are gonna right click in your data. You are gonna go to format data series, and then you are gonna erase the gap here, okay? So now you have a histogram, right? So once again, I'm gonna do it again. So I erased the label, I highlighted the information. So why did I erase this label? Because if I put this in a bar, so I'm gonna create two bars. But if I erase the label here, I am asking Excel to take this as the horizontal axis. And this is gonna be my information in the vertical axis. So I'm gonna do again, insert, chart, and column. So I right click on my bar, I right click, I say format data series, and I erase the gap, okay? So I put a 0 and then return. So that looks more like a histogram. So this histogram basically tells me the shape of my distribution. As we can see, among the prices that I am, let's say I am the owner of Best Buy and I am selling GPS. So it seems that this category of GPS are very popular among people. And probably this one is not very good. Probably people don't buy it because it's the reputation is bad. So if I was the manager, I will probably be making some decisions regarding my sales. So I probably will buy more of these because seems to be more popular, probably less than this. Some people might like some luxury brands, so that they might buy the most expensive. So probably if I was the owner, I will be making decisions based on the information. So in some cases, you have these class boundaries. So the class boundaries is almost the same as this. So what we are doing here, I am using the midpoints as the label of the bar. So you can also use the class boundaries. So to find the class boundaries, we can use the lower is gonna be minus 0.05. And then the upper is gonna be the upper limit plus 0.5. So as you can see, we are subtracting half a point here. We are adding half a point here. So we are gonna do the same in all the graphs. So, and we are gonna get numbers that are gonna be reflecting our class boundaries. So in this case, is like, it's kind of overlapping. So that's what we are trying to avoid here. But this kind of overlapping, like as you can see, 114.5. Oh, it's 0.5. So it's 0.5, sorry. So, so I say 0.05. So what happens is we are overlapping the upper bound of the first class and the lower boundary from the previous class. So it can be also the same. I like to use the midpoints because the midpoints are easier, but some people like to use these class boundaries. So all you have to do is to replace these numbers. For example, let's say this is 58.5 to 114.5, right? So what it's gonna do is gonna change the label. So this is 114.5 to 170.5. So it's happening, what happens is we are replacing the midpoints by the class boundaries. So it doesn't make any difference. So if we use, in this case, so we can use, so let me copy and paste this information here. I'm gonna paste it because it's already data. So, so let me go back and say 86.5 and 142.5, right? So those are gonna be, so, and here, instead of using the frequency, I'm gonna use the relative frequency, right? So I'm gonna use copy. I am gonna paste special because remember these numbers are values. So I want to paste the values. So I'm gonna erase or decrease the number of decimals. I don't like to have so many, can make me crazy. So I'm gonna create a frequency using the relative frequency. Rather than having the number of observations, I am gonna have these numbers expressed as a percentage, okay? Which is basically the same. I don't have to do any. So this frequency and this relative frequency are gonna be the same. What changes is that the vertical axis is gonna be expressed in percentages. So I'm gonna use the same insert, chart, column, and then I am gonna say format data series, and then I am gonna erase the gap. I'm gonna erase the gap, okay? So, and I have my histogram using the relative frequency. So as you can see, all these are exactly the same. So why am I creating something equal? Well, it's because it's the same data, but the data is expressed using different metrics. This is expressed using the number of observations. And as you can see, this graph is expressed using the number of the relative frequency. Is there any questions so far? Are you guys still there? Hello? Hello?
Yes.
Okay.
Yes.
So is this helpful? Is this helpful? Yes or no?
Yeah.
Okay. I hope you can use it because, I mean, yes. Okay. So
Yeah,
I'm
it's
going to
helpful.
assume that all the yeses are from this. So some of you guys say that you have experience with Excel. So I guess doing this is going to be easy for many. If
Yeah.
that is not the case for you, please let me know. I will try to make myself available for you guys. So you can, we can work together with this, okay? So far, I think we have covered a lot and we are covering still a lot. So we have a database, we ordered the database, we decided to create 7 classes. So we found the range, we have the number of classes, and then we found the class width. One, we found the class width, which is the range divided by the number of classes. We rounded up to the next integer, and then we use the lowest data point to start our frequency distribution table. So this frequency distribution table, from the lowest point in the lower limit, we added 56. Remember, 56 is the class width. So I did this for all the different classes. For the upper, I subtracted 1 from the second lower limit. And then after I got this number, I I added 56 to all of them. So as you can see, my data set ends in 450. So the last observation here is 450. So that basically tells me that I'm right. In some cases, if you don't round it up, you probably will be missing some of these numbers. So it's always good to round it up to the next integer, okay? So once we found the lower limit and the upper limit of the class, we tallied all these values. We found the frequencies. Frequencies is the number of observations that fall between this class and each class. Then we found the midpoint. The midpoint is the average of these 2 points. Then we found the relative frequency. Remember, the relative frequency is the frequency divided by the sample size. So that's what we found here. So in these two cases, we use the sigma to make sure that the sample size is correct and the percentage should be 100%. So then we did the cumulative frequency. This cumulative frequency is so is adding the first and then the first and the second, then the first, the second and the third, then the first, second, third and fourth, so on and so forth. At the end, this cumulative frequency ends in the totality of the sample size. And then we did the class boundaries. I'm not very happy to do it, but some people might say, well, I want to use the class boundaries. So this lower and upper limit has to be modified. You subtract 0.5 from the lower and then add 0.5 to the upper class, right? So in that case, you are finding the upper and the lower class boundaries, okay? So that's what we have done so far. We found the frequency, the histogram based on the frequency distribution. We did a histogram based on the relative frequency. What we can also do is to use a polygon. So what I did here, so I'm gonna create a line chart. So let me go back to my PowerPoints. So that's what we did today. So we followed all these 5 steps and then created our classes. So, and built our frequency distribution table. So what is good of these frequency distribution tables is that we can express the data that had no visualization in something that can be visualized and something that makes sense. I am finding the underlying distribution of that particular data set. So this is so we found the midpoint, the relative frequency, the cumulative, and the class boundaries. We produced the frequency histogram. We are going to do the frequency polygon. We did the frequency, the relative frequency histogram. We're going to do the polygon and the so-called ogive. Okay, so those things are very important in our information. So here, to create the so-called polygon, so what I'm gonna do is I am gonna use the midpoints and I am gonna use the frequencies. But instead of using a bar chart, I'm gonna use a line chart. So the polygon basically are graphs that we can use to look at the same idea. So a polygon is going to be a graph that touches the midpoints. So we are going to find a line that goes to this midpoint that connects this, connect this, connect this. So in this case, I added a 0. So my first midpoint is 86.5. So 86.5. So that's the first one. The second was 142.5. So to use the same thing. So I added an additional data here and an additional data below, right? So I use an arbitrary number that is higher. Probably was the previous one plus 56, which is the class width, just to create an additional observation. Why did I do that? Well, look at, so the polygon basically is a graph that connects all the midpoints, but at the end connects the origins. So I need to be connected to the horizontal axis. So that's the reason I created this zero frequency at the beginning and zero frequency at the end with these labels. So what I'm gonna do is I'm gonna create a line chart, So if I didn't use these values, let's see what happens if I don't use these values. If I don't use these values, that's what is gonna happen. So these points do not connect to the, they do not connect to the horizontal axis. So that's the reason I said, well, let's say 40 or 40, something like this. So it's a number below 86. I'm gonna add the 0. So, and then I am gonna add 470, 480, just to give a number. And I am also adding a 0. So as you can see, all the trick I did is just to add these two different ending. So this is a polygon. As you can see, the polygon is almost the same idea of the histogram. I can see what is the highest point, what is the lowest point, and what might be the points that I want to focus my attention on, okay? So polygons are very easy to make. In this case, the trick of my data, so I use the same data, but I added two different points. So I did it just to connect the ends of my graph and create a real polygon. So this polygon is a frequency polygon. So I can even modify the title. So there are many things that we can do. So the last one I want to show you for this is the so-called ogive. So for the ogive, I'm gonna use also the midpoints, and I am gonna use the cumulative frequency. So I'm gonna copy, I'm gonna paste, oh, sorry. Because those are values, I'm gonna say, no, I think I have to do it again. So I'm gonna copy, the cumulative frequencies, and I am gonna paste a special here, paste a special, I'm gonna paste the values, right? So let me erase this, and probably will keep this 40 at 0, right? So the ogive is gonna be, this is the frequencies, and this is gonna be the midpoints, right? So my graph is gonna start from 0, and it's gonna start rising as we move from point 1, from the first to the second to the third. So why do we want to do that? So I'm gonna insert a chart that is a line chart, right? So this line chart basically is telling me the following. So some of them are very revealing. This is not as revealing. For example, I can see that when I go from 0 to 1, so my graph rises and keeps rising. And at some point, when it gets to the price of 254, it seems that this growth starts declining and becomes more like flat. So some cases you can find graphs that are growing very fast at the beginning and then start getting even at the end, or some of them are growing exponentially. So that's what we want to see in the ogive. So the ogive is gonna help me identify how fast the information, the data increases when I move from point A to point B. So it can be very, very helpful in my computations. So, So as we can see, once again, we cover what is called frequency distribution tables. They are very helpful. You can do, if you have a big database, the first thing that you can do is to classify the data, categorize the data in different data sets, in different categories. For example, if you had people who are from different race ethnicities, so you are doing the census, you have a sample of people in your district, and for example, you can see how many people are Hispanics, how many people, so you are gonna use these labels and then the frequency. So that can be something interesting to do. So, so also I want to show you some of the other different ways we can visualize information. For example, with data, we can create a stem and leaf pies, line charts, bar charts. So those are things that we can do. So I don't like too much the stem and leaf graphs because they are very basic, and you can do it almost by hand. So that doesn't add too much to me because we have some other ways to do it. For example, doing these histograms can be very helpful, but in some cases you don't want to do a histogram, you just want to count how many observations in each category you have. So in this case, the stem and leaf, you create a plot and divide each observation of the data into stems and leaves, right? The leaves consist on the final significant digit. For example, if we have a 23, so the leaf is gonna be 3 and the stem is gonna be 2. So if we have a number such as 432, the leaf is gonna be 2 and the stem is gonna be 43. So we have to write them in vertical order, then draw a vertical line to the right of the systems, then write the leaves in increasing order to the next to their corresponding stem. So I did an example, extremely basic for us. So in these graphs, I had some data. And as you can see, the data is already sorted. So I don't need to do anything else. So what I'm gonna do is, so in this case, I have a data that starts in 99. So the stem is gonna be 9 and the leaf is gonna be 9, right? So the stem is gonna be 9 and the leaf is gonna be 9. So I don't have anything in the hundreds and in the hundreds and tens. So I'm gonna start with my second number that is 121. My stem is gonna be 12, and the leaf is gonna be 1. So 12 and 1. So as you can see, I drew a line here. So all I did is I call Excel and I said, Excel, give me the right border. And that's what they did. So they give me the right border. So I am gonna erase this line in the bottom because I don't need it. Okay. So I might need more of this. So I have so I already did this and then I did this. So I go to the next one is the same stem, but it's a different leaf. So my leaf goes here, 5. So I did this and I have a second one. So I'm gonna type 2 5s in the 120. Then I have a 6 and a 7. So 6, 7, and 8. So I'm gonna put a 6, a 7, and an 8. So now my next stem is gonna be 113. So I have a 0 here. So this is the 1, 0. Then I have a 6, which is this one. And then I have another 6, which is this one, right? So I'm organizing my data. So it's good that we organize the data first. And then the last one is 145. My stem is gonna be 14 and my leaf is gonna be 5. So 114 is gonna be the stem and 5 is gonna be the leaf. So what happens with these things is that So we can see what is the most popular, let's say, numbers, set of numbers. I can see whatever this data is represented, is representing the 120s are the most popular, let's say, elements on this data set. So if this is prices, probably people are willing to pay more these prices in the 120s. They don't like too much cheap stuff, I guess, or too expensive. So that can be an interpretation that we can do from our data. So the stem and leaf are interesting graphs. We don't use them too often, but it's good to know how to create them. They are basically informing what is the has the same idea of the histogram, but instead of facing up, is facing sideways. So this is the highest bar. These two are the smallest bars. So that's all we can say regarding this kind of graphs. So stem and leaf are important. So we start 7:30, okay. So pie charts are also very useful. They are very visual. Every time you want to make a point with your boss, you are gonna be able to show him or her what is the share of your of the most important items in your data set. For example, if I was working, I'm working as a professor at Lehman, so this is the distribution of people in my school. At Lehman, let's say 728 got an associate degree, 1525 a bachelor's, master's, and first professional and doctorates. So what I'm gonna do is I'm gonna create a pie chart so that they are very easy to create. So I'm gonna click on charts and then I am gonna use a pie. So very easy, all I have to do, including the labels I am including. So my pie is here. So I have the associates, the bachelor, the master's, the first professional, and the doctoral degrees. So I can do many things with my graph. For instance, I can expand it. This is too small, I want it bigger. So I can copy and paste it in one PowerPoint. Also, what I can do is if I right click in any of the segments of the pie, I can add the data labels. So, and this is very helpful because as you can see, I can look at the numbers here. Sometimes the numbers are important, but in many cases, when you express the numbers in percentages, probably make more sense. So what I'm gonna do is, once again, I'm gonna format the data labels and I am gonna choose the percentage and I am gonna erase the values, right? So I'm also want to know the category, so I don't get lost, okay? So you can create pie charts very, very easily. First professional 3%, doctoral 2%. That is easier to understand. Probably if I see the numbers, I will be scratching my head. But if I see the percentages, I can say, wow, these numbers, the 1,525 represent 51%. So for example, if I was the president and I want more research, probably I will be emphasizing the number of doctoral students in the school. I don't know, things that can happen. So, so that is the pie chart. It's a circle divided into sectors that represent different categories. So the area of each sector is proportional to the frequency of each category. So we also can prove that these numbers are correct. So remember, we can measure the relative frequency. We already know how to do it. So first of all, I'm gonna look at the summatory. So this is gonna be my sample size, remember? So all these numbers are the sample size. Then I'm gonna find the frequency. I'm gonna say frequency divided by the sample size. And remember, in this case, I am adding a $sign because the sample size is gonna be always the same in the computation of all of them. So as you can see, associate 24% is correct. So I do this all the way down. So 2% for doctorals, 3% for professionals. I want to know if I made a mistake. So these numbers have to be equal to 1, and that is correct. So as you can see, Excel is saving you time and is giving you it's expressing the values already in percentages. Okay, so continuing with our class, we have a Pareto chart. So that is also very interesting. So you want to highlight which one of the labels is the most important, and which one is the less important. So that happens with the Pareto chart. So the Pareto chart is a vertical graph in which the height of each bar represents the frequency or relative frequency. So the characteristic of this, or the main characteristic of this Pareto chart, is that the bars are positioned in order of decreasing heights, with the tallest bar positioned at the left. So here, I think, I don't know if it's difficult to see here. So I'm gonna make it a little bit bigger. I hope it helps. So we have the Pareto chart. So, so we have, you are in a company and you see that the company is losing money. So when you analyze the financial statements of your company, you realize that those are the main issues that are affecting the company. So, so basically what we're gonna do is we're gonna create, so in this case, because I'm gonna create a bar chart, well, first of all, so let me do this in the proper way. So first of all, as you can see, the Pareto chart says we need the lowest, the highest bar at the beginning, the lowest at the end. So I'm gonna highlight this information, right? I'm gonna ask Excel to order this from the largest to the smallest. But pay attention on this. If I say, okay, arrange this, it says expand the selection. So I will say in this case, yes, because I want the administrative error always be with the 5.4, the employee theft with the 15.9, so on and so forth. So I'm gonna ask Excel, expand the selection, meaning anything that is on the left or on the right has to move in the same way as this selection. So I'm gonna sort it, and as you can see, administrative errors were 5.4, vendor fraud 1.5, so 1.4, employee theft was the largest. So once I already created my my arrangement, I'm gonna erase the label of the first column, because remember, if I do that, I am asking Excel to use this as a label. So, and that means that these names are gonna be on the bottom, on the horizontal axis of my bar chart. So the Pareto chart is gonna be a bar chart, a column chart. So that is gonna be my Pareto chart. Of course, if I am talking to my investors, I'm gonna say, look, we need to pay more attention on the employee theft. So we have to put cameras. I don't know what is correct and what is not correct in these times. So, but you have the evidence, you have the numbers, so you are presenting this to an audience, and that is gonna be very visual, very helpful for you to make the point. So we also have, besides the Pareto charts, the paired data sets. Before looking at this, let me just show you some line and bar graphs. So here we did the line chart. So once again, I'm gonna erase this. So I'm gonna create a line chart with this data. So basically insert, again, I'm gonna do the chart and then the line. So that's gonna be my line chart. So it's gonna tell me some story about the information. So basically the highest number is 3. So here it was time. So this is the number of times, as far as I remember, the number of times the student was reminded of doing the homework. So you can see that in many cases, 3 times was the highest. So in many cases, I have to send 3, 4 emails before a student start responding to the homework I am asking. So this is 0 times. The students are so good that 2 of them didn't need a reminder. They did the homework before I sent a reminder. Then I sent the first, 5 responded, and so forth and so on. So this is a bar chart. So also this is based on age groups. So it's gonna be age groups. So I'm gonna copy this information and I'm gonna use a bar. So once again, insert charts, and it's more like column because bars are different. So in this case, this is my information based on age groups. So so that is the number of users of the internet, for example, and that makes sense. People who are young, very young, they use the internet, especially Facebook, I guess. So then people in the working age, so that they also use the internet a lot, and very likely people who are older, they use the internet less than other people. So that's very interesting. I can see the numbers, but once again, the bar chart helps me identify the trends in my data. So, so what else do we have? We have the Pareto chart. So we have the polygon. So in this case, we can do 2 polygons at once. So let me erase this. So this is, we can compare two different data sets. For example, in this case, this is a frequency polygon. We are analyzing information from grades in the final test and grades in the final grade. So this is the final test and this is the final grade. People who got less than 45.5, so I'm just adding these extremes, as I mentioned before, just to connect to the horizontal axis. But in this case, I have ranges or labels between 49.5 and 59.5, which is people failed the class, probably people got the lowest until the highest grade. So we have 2 different things. We can create 2 polygons that helps me see the difference between the 2, right? So this is the final test and this is the final grade. So I can see the difference between the 2 data sets. So that is something that in many cases is gonna help me. Let's say that this is, so this is class. So this is group 1. And this is group 2. So if I am comparing 2 groups, so that might be interesting to see how the 2 groups perform. So in this case, I can see that people with the highest grades are in the group 2 and then blah, blah. So I can see many things in the data. So is there any question so far? Are you guys okay? Are you still surviving? Okay, so I'm gonna believe that you are still there. So we already saw sorry. So we did the stem and leaf graphs, the pie charts, we did the Pareto chart. So and we jumped to the line and graph charts. So this data I copied and well, I put the same data in these graphs, in these Excel files. So it's exactly the same as what I did here. So this data comes from the book, so you can easily replicate the examples. So I tried to do the scatter plots before we close the class. So those scatter plots are beautiful. So you want these paired data sets. So we are gonna call them scatter plots. So scatter plots basically are figures. Let me tell you something. So we are gonna have, here we are gonna create a pair of, hold on, let me see where it's drawn. So here. So what I'm gonna do is the following. I'm gonna do, so this is, so I'm gonna do, so this is my Y and this is my X, right? X and Y, yeah. So this is the independent variable. This is the dependent variable. So in this case, I'm gonna argue that life expectancy Y depends on changes on X, right? So that's what the formula tells me, right? So I can express this with the equation of the straight line. Y is equal to A plus px, right? Where y is the dependent variable, x is the independent variable, b is the slope, and a is gonna be the y-intercept. So what I'm gonna do is I'm gonna identify each data point. So this country, Sierra Leone, has a very low GDP and very low life expectancy. So looking at this, I can argue that life expectancy depends on the size of the economy, so the GDP, right? So I can say that. So I can look at these different relationships. So I'm gonna create a graph when I am gonna find points for X and Y's for Sierra Leone. So Y is gonna be the life expectancy and X is gonna be the GDP. So I want to prove that as GDP grows or GDP increases, life expectancy also increases. So in order to show that particular relationship, I'm gonna use a scatter plot. So make sure that your independent variable goes first and the dependent variable goes after this. And the beauty of Excel is that you can do this with a short database, with a long database. So in this case, as you can see, we have a collection of 200, almost 200 countries. So can we create this by hand? Of course not. So creating this by hand is gonna be a pain in the neck. And we can do Excel. I'm gonna highlight my two different columns, knowing that the first one is the independent variable and the second one is the dependent variable. So once I highlight my two different variables, I'm gonna go again to insert, and I am gonna use chart, and I'm gonna use the XY scatter. So what am I expecting to see? Well, remember, I am assuming that there is a positive relationship between life expectancy and economic growth, or the size of the economy. The larger the economy, or the larger the GDP, the larger the chances of people to living longer. So that is my argument. So I do that, and I find out that I have this collection of dots. So let me make it bigger. So remember, each dot is a pair between X and Y for each country, right? So so I'm trying to get to the top and make this a little bit bigger. Well, it doesn't matter if I go to the top. So I was just trying to make this close to my graph. So as you can see, this is the so the Y is the life expectancy. I think the highest life expectancy is $90. So the lowest GDP is $500. The highest, I don't know, is like 60,000. So we can see here in a bigger perspective. If somebody asks me, do you think that investing in the economy or creating a better economy is going to be good for people? So you can say, sure, there is evidence that shows that as the economy grows, so we can see that if we move from the left to the right, and then we move to the bottom to the top, so as as the GDP increases, also life expectancy increases. So what we're gonna do here, and I think we're gonna stop with that. So what we're gonna do here, I'm gonna right click in any of the data points. So I'm gonna do that again. So I am gonna right click in any of the observations, can be any. And then I am gonna add the so-called trend line. That gives me a better perspective of what is the slope. So as you can see, as GDP increases, life expectancy also increases. So I was able to draw this line electronically, so I use Excel. So that is telling me that this is a positive association between the two different variables. So that means as GDP increases, life expectancy tends to be higher. So we can write even an equation for this. So when I added the trend line, I forgot to ask Excel. If you can see at the bottom, you have displayed the equation and display the R squared value on the chart. Keep an eye in these two different things because we're gonna use them very much in the next couple of days. So once we create a scatter plot, so we can do this, so we are gonna have some use for these values. So basically what is telling me that because this has a positive number, so the slope is positive, the y-intercept occurs at 58, as we can see here, and the R squared tells me something that I will use in another lecture. So what I want to tell you guys is that what I'm doing in class is what you have to do for yourself. So at the end of the first chapter and second chapter, or the chapters that we are analyzing, so you have to return these graphs as I am creating them. So that's gonna be the Excel assignment, to replicate what I'm doing in class, so you do it in your Excel assignment, and then submit it via Blackboard. So, so before I finish, I just want to show something else. So histograms, we already went through the histograms. So those are contiguous boxes, and it has an horizontal and a vertical axis. The horizontal axis is the labels that the data represents, and the vertical axis can be either the frequency or the relative frequency. So once again, histograms are very useful because we can see the underlying distribution of those data. So, so those are the frequency polygons that we created a few minutes ago, and this is the two ones that we also created we created in Excel. So So what I want to show before I finish this class is the time series. So this time series is a very nice way to represent information. Just imagine that you are following what is happening in the stock market every single day. You are collecting data on the closing number of the Standard & Poor's 500 or the Dow Jones. So that's what I did here. I want to know the trends of my information. So this is the stock market. This is the Dow Jones industrial average. So that this is from 2014. I think it's the whole 2000. So it's a data set that goes from different times, right? So I'm gonna create a time series. As you can see, these are dates and these are values. So in my time series graph, I'm gonna have here the time and here the values. So the values, the values of this Dow Jones Industrial Average. So what I'm gonna do here is I'm going to highlight this information, and I am gonna create a line chart. So insert, chart, and line, right? So I can see the information, even I didn't have to make any arrangements. Excel saw these values and said, oh, that one is the last one. Why are you putting this in at the end? So it's giving me an order data set of my information over time. So those are the values of the Dow Jones between 18th of November of 2013 and February 24, 2014. So in many cases, if you are in finance, so there is something that is called the moving average, or even if you are not in finance. So this idea of the moving average is a very good idea because helps me to make this line smoother. Like for example, I can see that the market is fluctuating a lot, right? So the market is going up and down every single day. How can I predict changes? How can I make money in the stock market? Well, if you look at Bloomberg or the Wall Street Journal, they use something that is called the moving average. Of course, this is a very spread database. So what they do is they look at the information that is coming every minute, every second. So they are able to make this line smooth and predict changes in the trends. To do that, they use the so-called moving average. So we are gonna do the average of these 5 observations and then the average of the next 5 and then the average of the next 5. So we are gonna be looking at this information, and the average is gonna be reflected, in smoother changes. So let me tell you what I mean by that. This is 1, 2, 3, 4, and 5. I'm gonna use the 5 first observations, and I'm gonna take the average of these numbers, right?
Oh, you don't hear me?
And I'm gonna do the same for all of them, right? So I'm gonna do the same for all of them. So if I put these 2 graphs together, what is gonna happen? Well, what is gonna happen is that they are gonna overlap, but one of them is gonna be smoother than the other, right? So as you can see, we can predict changes in our data by just looking at the values, right? So what happened is, so once again, this moving average helps me predict changes in the data over time. So as we can see, So here, the market is being very volatile, but suddenly this line is recognizing that the market is gonna fall. So even though the market is increasing here, so this moving average is telling me that the market is gonna declining at some point. So here is the opposite. So this moving average is very nice if you can do some research on that, so you can find very good applications. So I think that's it for today. Oh, sorry. I think that's, what did I do? Recording. So what did I do? So is there any question?